All right, our next speaker up here is Kamesh from Dell. We've actually been working with Kamesh and his folks over at Dell for quite a while now.
Yeah, 2 years actually. Yeah.
Yeah. So we've had some really good interactions, and what was our first big one? University of Alabama. We worked
I'm
together
going to talk about University of Alabama.
Oh, good, great.
It's our key, marquee customer for Ceph.
So there have been a lot of really cool things, and these guys have been kind of boots on the ground and done some really awesome stuff with customers and Ceph with Dell hardware. So without further ado, I'll let Kamesh take it away.
Perfect.
Thanks.
Thank you very much. Hello, everyone. Caffeined up and ready to go. All right, so I'm Kamesh Pemmaraju. I work at Dell. I'm a senior product manager. I focus on OpenStack specifically, so you'll hear a lot about OpenStack today. And of course, how Ceph and OpenStack work together is kind of my main focus. I also host and organize the OpenStack meetup in Boston area. So how many of you are from the Boston area? Local? Great, perfect. So in fact, every month we meet to talk about all the open source projects, OpenStack being the main sort of focus for us. So as a matter of fact, tomorrow is our next OpenStack meetup, and we're going to be talking about Hyper-V. Peter from Microsoft is here. He's going to talk about that. So if you're local, go check it out, OpenStack Boston meetup. Do Google that, and you can sign up and be part of the community. We have over 900 people in the community in the Boston area. And we talk about all open source stuff around OpenStack. So just a plug there quickly. So what am I going to talk about today? So I spend a lot of time talking to customers. That's my job. And I talk about open source cloud implementations. I talk about open source storage. I talk about scale out storage. I talk to enterprise IT. I talk to service providers. So I've got a broad background of customer interactions. And based on that, I've sort of distilled some of the things that I'm seeing in the industry. So it'll give you an idea of how Ceph is getting adopted, what areas is it getting adopted in, what kinds of use cases seem to be resonating with customers, what use cases are still not there yet in terms of customers' perceptions. So the reference architecture stuff that we've been working with InkTank over the past couple of years help you sort of narrow down all the different things you can do with Ceph. I like to think of Ceph as a Swiss Army knife. You can do a lot of different things with it. It can fit a lot of different use cases, but then you can quickly get lost in the forest. So you need to really zero in on what use cases make the most sense, and then build reference architectures for that. And that's kind of what we've been doing with InkTank. And that's not enough. You also need to come up with, okay, is this reliable enough? Does it have the performance characteristics? Do we have the benchmarks for that? All that stuff comes into consideration. So I'll talk a little bit about what the RA considerations are, the lots of considerations, just because of the way Ceph is. You have all these building blocks. You can put them together in a lot of different ways. So I'll give you some ideas of what to think about as you consider for reference architecture. And we have Dell reference configurations that I'll talk about briefly. But the main topic, I guess the second half of my talk, is going to focus on University of Alabama that we just talked about, a major implementation of Ceph and OpenStack. So I'll sort of walk through what they were faced with in terms of challenges, what they had, and I'm sure a lot of this will resonate with you in terms of what you have in your own data centers. So this is the usual stuff we go through, but you talk about business considerations and budgets, et cetera, but guess what? The way Ceph is getting adopted is bottom up, as Sage mentioned earlier, right? So some open source developer in the enterprise downloads the open source Ceph bits, plays around with it, gets excited, does a little bit of an implementation of it, and then says, wow, we need to use this stuff, right? And then at some point, the organization, the CIO or director of IT or whoever gets involved and says, okay, what's the budget for this stuff? Why do we want to use this? Why do we care? What are the use cases do we want to use this for? What applications do we care about? So all those questions come up, and at some point you have to answer them, right? You have to answer to a CIO or to your director of IT or your executive, whoever it is. You need to make those cases, and I have some advice for you along those lines. And then there's a survey. By the way, Ceph is the second most, I believe the most popular backend for OpenStack, according to user surveys. LVM being the number one, the Linux volume manager. So again, what are you looking to build out of this? What is the initial storage capacity? Are you looking at steady state data, or are you looking at spike data usage at certain times of the year? What is the expected growth rate? So I guess you have to, at some point, once you feel comfortable with the technology, you have to start thinking through your pilot and pre-production environments. And ultimately, it's all about workloads, right? Use cases. So is it more capacity focused? Are you looking at archival use cases or backup? Or are you looking at high performance? Do you want to put a database on Ceph? Is that a good idea? Well, I'm going to talk about some of that. What type of data is involved? Is it ephemeral data? Is it scale out, multi-tenanted cloud environment? Or is it persistent data that you want to keep between VMs as they disappear? Is it object, block, file? Lots of considerations. So we're going to talk about some of that. And like I said earlier, Ceph is like a Swiss Army knife. It has all these different things. It can be tuned to a wide variety of use cases. Let's look at some of them. So this is a thing that I use. So you have kind of two different target users, if you will. Traditional IT that uses traditional SANs, NAS devices, virtualization and private clouds using Microsoft or VMware. And then you have cloud applications. So kind of think of them as legacy and modern in one way, right? Another way of looking at it. So here you have XaaS, infrastructure as a service, storage as a service, platform as a service, or you're looking for a compute cloud like Amazon or OpenStack. So you've got both of these type of things. So are you looking at capacity or performance? So these are the two things you need to think through. Ideally, Ceph sort of fits right there in the middle. Although I can make a case, because I've seen some very compelling performance numbers, where you can even replace Ceph, replace a traditional SAN with Ceph. And in fact, within Dell, this is a big argument that's going on within our storage group. We have compellent and equal logic, which are traditional SANs, just like NetApp and EMC has. So they're saying, hey, what's going to happen with our technologies? Is Ceph going to go replace this in the long term? We're having those discussions today, and it's not an easy answer. Right now, Ceph is maturing. It's good for certain use cases like dev test, and I'll talk about what those are. But I think this is a nice sweet spot for Ceph right there. I wouldn't really recommend Ceph for very high performance, EMC and NetApp type of storage devices where you put mission critical, high performance databases and stuff like that. Not right now. But that's sort of a nice target because it fits a lot of different use cases. All right. So the use cases, I'm going to talk more about OpenStack because that's kind of where my main focus has been and where I'm seeing a lot of customer demand. OK, so here we go. This is really slow. OK, there we go. So if you look at this one, we have the content store. So you can look at Ceph as an object store, similar to Swift. You can also look at it as a backend for OpenStack. So let me talk about some of the specific use cases of Ceph that we are seeing, and some that I think that Ceph is good for. The main one is OpenStack, obviously. And Ceph has both a Swift API compatibility as well as a Cinder API compatibility. Cinder, by the way, how many of you are familiar with OpenStack? OK, quite a few of you. Great. So the Cinder is the component for volumes and block storage. So the Ceph block device is what you would use to interface with the Ceph cluster through the Cinder API. So we've got the volume interface as well as the Swift object interface. So we're seeing a lot of object right now in terms of customer traction. And they're using it for both ephemeral storage as well as snapshots, copy and write, and volumes. Now, an interesting benchmark that our storage team did, it turns out, actually, if you use ephemeral storage on the Ceph cluster as opposed to the local disk, it's actually faster in terms of throughput, which is kind of a surprise to me. But it turns out it's actually faster if you just use ephemeral on Ceph. The other reason you would want to use Ceph for Cinder is because you can also have your images hosted on the Ceph cluster. What happens typically in OpenStack is if you don't have a Ceph cluster like this, the image gets downloaded from Glance onto the local node before it boots up. So there's a overhead in terms of moving the image over. But if it's on Ceph, it's right there in the Ceph cluster. So your boot up times are a lot faster. So you'll get some benefits from using Ceph for both Glance and Nova as well as Cinder. So in the case of OpenStack, obviously the Ceph platform is certified against the Red Hat things, which is an advantage for you. Now, the other use case is just pure cloud storage. If you want to use it as a pure object store, like a Swift cluster. You can use the object gateway and the Rados cluster as the backend object storage. The third use case is web scale applications. Now here's an interesting thing. So here we're using the gateways and the APIs to get to the actual cluster. But if you want to get very, very high performance, in fact, I think the performance difference between going this route versus this route is an order of magnitude faster. So you're going directly to the Ceph Rados cluster using the native protocol. So this gives you an enormous amount of flexibility in terms of performance and scale and multi-tenancy. Now the latest version of Ceph, which is the Enterprise Ceph 1.2 Firefly, has the multi-tiered caching that's available. So now we can sort of set up a performance block configuration just like that. So you can use the cache pool and the backing pool for your volumes. So you can, for read-write, you can use the cache for write-back mode, and for read, you can use cache as read-only mode. So both modes are available for the performance block. And Sage mentioned earlier with the erasure-coded feature that's coming in, that's already there right now in ICE 1.2, you can use it for cold storage. And that'll give you a lot of additional, first of all, it'll save you money because you don't have to spend as much on storage, because it's going to cut down the number of storage nodes you need for the same amount of storage. And you can use the cache pool for basically increasing your performance for reading, because this is a good read-only use case. And then, like I said, for databases, again, go native protocol, because this is the way for you to get performance. Using the Ceph block device and native protocol, you can, in fact, put databases on Ceph. Now, I wouldn't recommend this yet. Yeah, I would highly recommend you do your own performance testing with your own sort of reference architecture before you can go down this road. But the thing I'm trying to point out is there are ways in which you can use Ceph for different use cases, because it supports it using these different protocols. And then finally, Hadoop, as Sage mentioned again, Ceph file system, once it's ready for production, it's a great replacement for HDFS. So these are the things we're seeing. And in terms of architectural, so let me get down into a little bit about the architectural considerations. So the questions you need to ask yourself, right? Is reliability important? In which case you have to look at redundancy. If you have 2x, 3x, 4x redundancy, there's a cost trade-off. So it's all use case dependent, right? So that's one trade-off you need to look at. The second one is all about failure domains. There are lots of different failure domains to think about. The disks can fail. Your SSD journals could fail. Your node, the entire node can go down. Your entire rack can go down. Or a complete site can just disappear because of a natural calamity. So each of these failure zones is what you can, when you're designing your Ceph cluster, think through your crush configs to map out what the fault zones are. And that way you can start to put disks and nodes in different racks. So in case one rack goes down, you still have another rack to take care of it. And then think about the storage pools, right? Do you want a high performance SSD pool, which will give you that block performance I mentioned earlier? Or is it just capacity? You're looking for large scale, low cost, we call it cheap and deep, right? Cheap and deep storage. Just large archival for your object storage. Then you need to look at a capacity pool, using erasure coding as a potential for reducing costs. And the monitor nodes, right? The monitor nodes, you have to think about their failure domains. You don't want them to be in the same failure domain, because if that goes down, all your monitor nodes go down, in which case you don't have access to your cluster. So consider all these failure placement scenarios, lowered redundancies and performance impacts as you design your Ceph cluster. We have some considerations in the reference architecture that's coming out. We are designing a reference architecture for the most common use cases, and that'll be published in a month or so with InkTank and Red Hat. So that's the high-level architectural considerations. When it comes down to the servers, the storage nodes itself, how many OSDs do you need, right, per hard disk? So the general rule of thumb is one OSD per hard disk, right? So we're looking at about 1 to 2 gigs, 1 gigahertz per core per OSD. So that's kind of the rule of thumb for that. If you can use SSDs for journaling, which will speed up your write performance. And then, of course, you can have tiering, which is in Firefly, which will allow you to use both SSD pools as well as backing pools. So you can have both of those things. But think about what happens when your SSD fails. So we were having a big discussion internally, is if you have a node with, let's say, 12 disks in it, and you dedicate 10 disks for your data nodes and 2 of them for your SSD journals, what happens if one of your SSD journal nodes goes down, drive goes down? What kind of impact does it have on recovery? Do you want to make your SSDs redundant? Meaning, do you want to use some kind of a RAID 1 configuration or mirrored configuration for that? So at the end of the day, we sort of came to a nice sort of compromise in which we said you need to have a 5-to-1 ratio between your actual data disks and your SSD journal devices. And that way, if you have like 10 disks, then you need 2 disks for SSD, effectively in a single node, right? So that gives you enough of a capacity so that you can take care of those things. So erasure coding, as I mentioned already, you can get a lot of additional storage benefits, but the expense of compute. So I think Sage had a slide which was showing what happens for recovery times when you use erasure coding. It goes up dramatically, and it has a tremendous impact on compute. So you need to think about that. So for extra capacity, you can think about JBOD expanders. Dell, for example, we have these MD 3060 series. There are 90 disks in a chassis. It gives you, at 4 terabytes per disk, 90 times 4, you're talking about almost half a petabyte in a single chassis, full of just JBODs, just disks, just a bunch of disks, which you can hang off of a server, like a storage server, to get this extra capacity, huge capacity. If all you're interested is in storage, cheap storage, that's the way to go. But you have to be careful because now you will be adding extra latency because now you're oversubscribing your SAS lanes, right? So we have come up with an RA that kind of takes that into consideration. We've done some testing along those lines. Monitor nodes, we need odd number for quorum. Services can be hosted on a storage node itself. You don't need dedicated nodes for monitor nodes if it's not a very large cluster. But a fairly, between 10 to 20 is sort of the guideline. If you have 20 nodes, let's say each node is about 30 to 40 terabytes, then you're okay. You'll still be fine having your monitor nodes hosted on the storage node itself. But if you're going beyond that, we recommend having dedicated nodes, right? So a dedicated node just for running monitor services. Keep in mind that monitors are relatively quiet for most of the time. They'll only kick in if there's a change in the environment or if the environment is not stable. So if there's failures happening all over the place, then the monitor nodes kick in. There'll be a lot of traffic, and there's a lot of chatty traffic between the monitors. But if it's a stable cluster, your monitor node is not really doing anything. It's sitting there idle. So keep that in mind. And if you're doing distributed geo distribution and you want replication across sites, then what you want is dedicated RAIDOS gateway nodes for large object stores that are distributed across multiple sites. So you can use dedicated RAIDOS gateway nodes and use federation between those sites to synchronize between the sites. So these are all the server considerations. So depending on how big it is, how geographically distributed you are, what kind of redundancy you want, what kind of performance you want, should you use SSDs, et cetera, et cetera. These are the things to think through. Networking is a huge, huge thing you have to make sure you think through right from the beginning. Because guess what? We have had several customer installations where we had all these conversations with the customer, we were ready to go deploy the thing, and all of a sudden at the last minute, the networking and security teams come up and say, huh? What are you guys doing? So we had to go back to the drawing board effectively and say, okay, now we're going to connect this to your backend, core fabric and the firewall rules and how it's supposed to be all connected. So make sure you bring those guys in right from the beginning. Unless it's a completely isolated cluster, which is usually not the case. You're connecting it to something, right? Some other services or something. And you'll see in the case study that that is the case. Do you want network redundancy, meaning multiple switches, multiple links going to your servers, or are you okay with one single switch? So that's another thing to think about. Do you want dedicated client nodes, client networks and dedicated data networks? Again, it depends on your use case, how much traffic you think you're going push through your data network. So think through that, 1 gig versus 10 gig versus 40 gig. Some customers, in fact, a big telecom customer based in the Boston area, I won't name the customer, but they've been working with very high-end Ceph implementations with 40 gig networks. In fact, our friends at Mellanox were with us working with there. And what their use case, and I was surprised when they came to us and said, we want to use Ceph for streaming video. It's a video on demand application, right? And they were talking about tens of thousands of users using all kinds of different form factors of end devices streaming video. And this stuff is basically doing translation and transcoding, all kinds of stuff on the fly. So okay, well, they were doing some testing of that, performance testing of that. I mean, it just goes to show that Ceph can be used in all kinds of different environments. Lots of different networking designs possible, spine and leaf, multi-rack, how are you going to connect your racks, core fabric connectivity, and if it's a geographically distributed system, the first use case that the case study with UAB, this was back before dumpling, by the way. So their main data center was in Birmingham, University of Alabama, Birmingham, and they wanted to have a backup facility in Huntsville, which is about 100 miles from there. They had a dedicated WAN link, but when we did the actual testing, we found out that the latency was not fast enough, and at the time, InkTank didn't have the replication feature. So as you know, right, Ceph uses, it's consistent. It's not eventually consistent, it is actually consistent. So it requires all of your nodes to be on a pretty high network with low latency. So keep that in mind. I think the newer things that are coming out in ICE, 2.0 and 3.0 will solve some of these problems. But right now, our recommendation is stay within a data center. If you want multi-site replication, wait for a while. We can still do it today, but it takes a little bit of magic to make it work. So what we've been doing at Dell, we've been working with a number of distributions, as you probably know. We started off with Canonical distribution. We've been working with SUSE, and more recently with Red Hat. We've been building reference architectures, testing out these solutions on these different distributions for a while. This is the latest version that's coming out. In fact, our first Dell Red Hat OpenStack solution was announced at the Red Hat Summit in April. So this one's coming out in summer. So effectively what it is a pilot configuration. If you want to start with OpenStack and Ceph, this is the best way to get started because it's effectively OpenStack in a box. OpenStack and Ceph in a box. Completely pre-configured, pre-tested. It's got all the servers you need. It's PowerEdge R from Dell. 720XD are the storage servers. 10 gig networking, Red Hat Enterprise, OpenStack Linux, and ICE 1.2, all built into this. All ready to go, pre-tested. You get up to 36 terabytes of raw storage in this box. It's actually 3/4 of a rack. It's not even a full rack. So if you want more storage, you can throw in more of these storage bundles, which is kind of an expansion feature for this pilot bundle. So this gives you 228 virtual machines, 36 terabytes of raw storage, which you can use either as volumes, backend volumes to OpenStack VMs, or just as a object store. You can do that. And it's got an OpenStack manager and OpenStack controller all built in with HA, so 2 additional nodes for HA. So this is coming out in summer. This comes with a reference architecture. So all the considerations that I just mentioned we have been having lots of internal debates and discussions both with InkTank and Red Hat and the Dell storage team. And we've finally come up with a solution that we think is optimal for a wide variety of use cases. And that's what that is, right? So you can use Ceph and OpenStack. And you can expand this out to multiple racks if you're looking for a capacity configuration, which is these Dell server configs are some examples. So the performance, capacity, and extra capacity. You can go with the 3 different possibilities. So if you're looking for a performance use case, you want to put a database on this, or you want to use it as a test dev environment for builds and testing and scale-out testing and stuff, the performance server would be your best choice, right? It's got SSDs. SSD pooling is not introduced yet. That's coming in version 2. But this gives you journals with SSDs and 40 terabytes of data in a single server. 120 terabytes in 3 servers. So it's pretty it's pretty dense. You get a lot of stuff there. If you want to go capacity, then we have these MD JBOD chassis I was talking about. So this MD 3060 or MD 1200, they're basically these large JBOD chassis with lots of disks in it, right? So you can build them out. Again, think through, and the configurations will make sure that you're not oversubscribing your SAS lanes or your latencies are getting affected, et cetera. But we have done some internal testing to make sure it fits the needs of that particular use case. So what are we doing to enable? Dell and Red Hat, specifically, this is the Red Hat solution. We have a similar solution with SUSE, and SUSE has been testing Ceph as well with our solution with Dell hardware. So that's also available, but specifically with Red Hat, it's a validated RA, co-engineered between Red Hat, InkTank, all three parties, effectively. We have been working with InkTank for over 2 years, and then the Red Hat acquisition happened, and we've been working with Red Hat too for the last 6 months, so it's a nice, marriage made in heaven, so to speak. So we have pre-configured storage bundles, storage enhancements, certification, professional services, all nicely bundled together. So you get everything out of the box ready to go. So with that, I'm going to jump into the case study. So University of Alabama, what was their biggest challenge? So they do a lot of great research in cancer and genomic research, right? This is kind of their focus. They have close to 900 researchers. Their biggest challenge was data sets, right? So they had this research data effectively scattered across all kinds of devices, USB sticks, hard disks, desktops, laptops. It was all over the place. They had a compliance issue, and they had this problem of managing the demand of these researchers, right? So the data was at risk, productivity was going down because people were not finding the data that they were looking for. They badly and desperately needed a centralized repository for the data, mainly for compliance, and for the demand that was coming up. And this is how their system looked like. It was a mess, right? They had all kinds of grids, they had local servers, they had prototype cloud set up with all kinds of open source clouds. They were using CloudStack, they had an OpenStack thing going on, they had virtualization. I mean, I'm sure there's a lot of typical enterprise data centers look somewhat like this. It's not very unusual. In fact, when we talk to the other universities, I can draw exactly the same picture, and it'll look the same across the board, right? So this was their situation, and they were using HPC. I mean, at the end of the day, this is an HPC application. They were doing genomics, large compute performance type stuff. And they were pushing all this stuff into the HPC cluster, which is, of course, connected on InfiniBand, and they've got all that stuff. They do all their processing, put all the storage in HPC storage, and then pull it back into their laptops for doing some local processing. So this is kind of how it looked. And it was all on 1 gig network, right? The interface to the HPC was 1 gig network, which is slowing them down. Lots of challenges with this. They were really looking to move to a modern infrastructure and a better way of managing their data, right? So the solution was a scale-out storage cloud. And OpenStack, Ceph, and Crowbar, which was Dell's deployment tool, really came to the rescue. So they were able to house and manage a centrally accessible, across the campus network, storage cloud. File system clusters can grow as big as they can because it's all centralized. It can be provisioned from this one single massive pool as opposed to being distributed all over the place. So it helps a lot with compliance. 400 terabytes, they put 400 terabytes into production when they started off. And they did the math, and it came out to be 41 cents per gigabyte per month, which is actually pretty darn good. Because if you look at, it's comparable, I don't know if it's comparable with Amazon, but it's pretty darn good. Very nice cost structure there. And they're looking to scale up to 5 petabytes over the next year or two. So the researchers were very happy because now they can work with much bigger data sets. They can save their workflows for new devices and analysis. They qualify for grants because now they have better levels of protection. At the end of the day, they were so happy with this initial thing that they're now looking to, and they were using other things too, like research storage, crash plan. They were doing GitHub hosting on POCs, et cetera. So this is how it looks today. There's a cloud services layer. It's all Ceph right now. They have this virtualized server and storage computing cloud based on OpenStack and Ceph and Crowbar, which is a deployment tool. We can talk offline about that, but it helps you with deploying these massive clusters automatically, right? Doing all this by hand is not easy, trust me, because there are a number of considerations all the way from configuring your servers, your networks, getting all your OpenStack services up and running, all your Ceph services up and running, tying it all together. It's not an easy thing to do. So Crowbar is, and there are a number of other tools too, like Foreman, and a number of other tools can do similar stuff, but that's a key component of any deployment infrastructure. So this is what it looks like. They have a number of Ceph nodes. They have a POC running for OpenStack. They're primarily using it for storage as a service right now. And their POC with OpenStack, and now it connects on a 10 gig network to their research HPC cloud. So that's what it looks like today. And they want to expand this beyond just data management, right? Now they want to have scientific computing. In fact, they want to host HPC on OpenStack, which is awesome, but I'm kind of scared of that, but we'll see how it goes. But we're working with them on that. They do want individualized, customized, dev test environments on OpenStack, which is a great use case. It works well. Most of our customers do that. And they want to start integrating shareware, open source, and other commercial software into this. It's an ongoing exercise. It's probably going to take them 2 or 3 years before they get all this integrated. But their vision looks somewhat like this. So eventually, they want to have this cloud services layer, OpenStack, and OpenStack doing all their infrastructure as a service in terms of providing virtualized server and server resources to their researchers, as well as an enterprise IT. And then the Ceph nodes effectively playing 2 roles. One is the storage as a service. This is the first thing they started off with. And then being a backup store or a volume store for the OpenStack nodes. So both of those, and eventually also connecting all to their HPC cluster. So this is the vision. It's going to take them a couple of years. We're working very closely with the customer over the last 2 years. They're very happy. In fact, we did a couple of sessions at the OpenStack Summit. The customer was there on the stage with me talking about some of the stuff.